James sets out by first finding the shopping basket. For this it uses the 3D point cloud from Kinect sensor and principal component analysis based method in order to estimate the bounding box around the shopping basket. Once it finds the basket, it uses a proprioceptive feedback from its fingertip sensors in order to refine the basket's pose and grab the handle. Subsequently, James checks the aperture of the gripper to verify whether the handle was grasped or not. After the basket was successfully grasped, it becomes part of the collision model of the robot. James moves to the predefined pose in front of the shopping rack in a collision-aware mode and tries to detect objects using planar segmentation of the shelf in the 3D point cloud. All objects standing on the detected shelf are segmented into clusters using an Euclidean measure. Clusters' centroids are finally taken as grasping points. The instances of objects are recognized using an algorithm that combines SIFT features in vocabulary trees for matching. Objects are put into basket using a pre-taught arm trajectory. James moves to the second predefined pose in our testbed kitchen and empties the basket slowly on a counter, which will in our future work enable us to segment the objects interactively in the clutter, grasp them and finally store them to the places they semantically belong to. Emptying of a basket includes measuring the feedback from James' fingertip sensors and synchronization of both of James' arms. In the second part of the demonstration, James grasps the objects, recognizes them and infers the semantically closest place in the kitchen that the object belongs to. James uses a prior knowledge about the environment it is acting in. The environment was first reconstructed using methods from 3D point cloud processing and then manually annotated in order to assign semantic meaning to various kitchen containers. For example, the refrigerator. For the object milk, a refrigerator was inferred as the best put-down location. The inferences for the latter are computed based on the ontology of objects and the web similarity that the milk object has with respect to all other objects in the ontology. Web similarities have been first used in the semantic information retrieval field. Top web similarities are listed in the top right corner. James moves to the predefined pose in front of the refrigerator and opens it using an a priori learned articulation model which is saved as part of James' environment model. James detects the handle in the same way as it detects the objects on the shopping rack, only this time the supporting surface, that is the refrigerator's door, is vertical. Once James opens the refrigerator, it finds the largest horizontal plane inside and places the object in the middle of it. To close the refrigerator, James plays back an inverse opening trajectory.